ATP synthesis, this is energy manufacturing mechanism, lies in increase in chemical potentials with increasing hydration of small cations and polyphosphate anions in the highly structured interfacial aqueous phase of the two phosphorylated intermediates. In other words, water is responsible for bringing about ATP synthesis. Water is the source of energy. Good, I'm glad. Who knew that? Who was it that knew that? Raise your hand. Okay. Now, also, water produces high heat of activation at the cell membrane. This is a very important information. Heat is a source of energy. We all know that, okay? The body has learned to use this heat generated by water when it rushes through the cell membrane and trap and bond or bind calcium molecules together. As you know, when you heat water, the calcium in the water furs on the side of the kettle. This is the property of calcium. When it sees heat, it immediately grabs its brother, another calcium molecule, and they hug each other. They unite and they bind. The body uses that heat in order to bind calcium atoms together. Because later on, the body also knows how to separate these brothers, calcium molecules, apart and release the ATP energy that is stored in the calcium bondage. So with this information, you all know now that your bones are primary reservoirs of energy. Dehydration will unlock this energy and release the calcium, and gradually the bone will begin to lose density. That's how osteoporosis begins. Okay? This is a very important piece of information, that dehydration is background to release of energy from calcium bondage, initially at the endoplasmic reticulum inside the cells, and subsequently gradually from the bone structure. Now, you all have heard of ATP. Magnesium ATP is the element that needs to be broken down for its energy to be utilized. Unless there is water available to hydrolyze it, that magnesium ATP has no energy value, because its energy content is only 600 kilojoule moles of energy. This is a unit of energy. But when it's hydrolyzed, it becomes almost 6,000 units of energy. So a tenfold increase in energy because of hydrolysis. And this guy here, hydrogen ion, which has 1,168 kilojoule moles of energy in each reaction, is there to be tapped into. It's available straight away. Now, the next one is water is the adhesive material. This is a cell membrane. This is a well-hydrated cell membrane. This is a dehydrated cell membrane. I designed this slide in order to explain the difference. Water, in going through this unit here, binds the top of the tuning fork, because this is an element that is a hydrophilic cap and a hydrophobic bitail. There are two, each unit has got two tails. Water binds these together. That's how stickiness of ice comes into binding the cell membrane together. But immediately, once it gets into the main waterway, the bilayer membrane, it becomes again another structure of water. And in the process, these are hydrophobic elements begin to repel water, and they create a wave sort of a thing. And in this waterway, in this moat area between the two layers, is where all the chemical reactions in the cell occur. When something comes into the cell, an enzyme, it has to meet its substrate, its friend in arms, in order to perform a chemical reaction. It seeks it in this area, and these hydrophobic tuning fork vibrators, which cause stirring, will help it along in order to move and perform the chemical reaction more efficiently. Another important element is that in dehydration, the feedback mechanism, which depends on this activity, is shut down. So part of the process that occurs in dehydration is that the body, once it gets engaged in a chemical activity or a stream of activity or a cascade of chemical reactions, it gets stuck on there unless there is water to hydrate the bilayer membrane and allow the feedback mechanism to shut the chemical reaction off. This is something that's very important for control of all hormones and physiological activity that depend on feedback mechanism. Water is vital for that function. Now, when there isn't water available, something still has to stick these things together. That's where cholesterol comes in. Traditionally, cholesterol is a clay-like material that sticks elements together. The human body, or any living matter, including bacteria that don't have nucleus, produce lipids, cholesterol, to bind things together. And when bacteria go into inactivity and are preserved for years, that is how they've done it. They completely shut themselves off. And this moat-like area also gets shut off because the elements go into one another and prevent any float laterally, sideways, so that reactions don't take place. Now, medical science is stuck on this aspect of water. Water has life-supporting functions. They completely forgot about life-giving functions of water. We concentrated on water as a solvent, as a packing material, and a means of transport. That's why science of medicine is incomplete. And on incomplete information, we have built a tradition that takes charge of people's health and not do well by them. The brain is 85% water, and the rest of the body is 75% water. In fact, I have a reference here by John G. Watterson, who is a physical chemist, and he's produced the role of water in cell architecture and explained that a brain is 85% water. And he's explained how water gels things together, how it becomes sticky like ice. Water, when it's compressed to a thinness or thickness of 2.5 angstrom units, it becomes sticky like ice. Brain is 85% water, and it's 1/50th of the total body weight, and the body is 75% water, but the brain takes priority, and that's why it allocates to itself 20% of the circulation. So brain has priority over water distribution because it has to perform physiological functions that are water dependent. It cannot endure dehydration, and that's why the brain becomes a reactive force in the body against the rest of the tissues in order to bring to itself the primary raw materials at the expense of all the other tissues of the body. The human body is packed with probably, I haven't counted them myself, but I'm told there are 100 trillion cells in the body, approximately. And each cell is a water-dependent species packed together within our skin, and we should consider our skin as the capsule of a water-dependent satellite or a space capsule of these water-dwelling species that have come on land. Each cell has a lot of receptors, whereas in our society we have these dishes that we use electromagnetic wavelengths in order to communicate between people and countries and societies. All living matter that live in water have the same sort of receptor dishes, but they use chemical messengers, not electromagnetic, because their medium is not air, it is water. Everything has to flow and reach the destination by swimming to its receptor. And that's why each cell has got a bilayer membrane, because it has to protect itself from entry of anything that is not directly impacting the physiology inside the cell. So each cell has got selective receptors, and these receptors are only sensitive to elements that concern the activity of that cell. There are basically two oceans of water in the body. There is one ocean of water inside the cells of the body, and then there is an ocean outside of the cells of the body. The water that we